Good afternoon, ladies and gentlemen. I hope everybody's wake up. I'm asleep myself. I'll be very, very fast because if I go just like everybody, I take 1 hour. So I'm going to be very fast. The title of my presentation is Technical Textiles, the Impacts and Investment Opportunities in Egypt. Contrary to traditional textile products like apparels, technical textile is a completely different story. In one way, the consumer goes to the manufacturer for asking for technical textiles and hand him a technical specification as to stick to the technical specification. This is very different from the apparel story, as it goes from the textile designer to the market, and you choose whatever you want. So I'm going to go first, okay, to different applications or to this figure. As we can see here, this is the market share of technical textile of Egypt, the red color, compared to countries like United States, Japan, and West Europe. Until the year 2000, we have come to 14% as technical textiles represented in the whole production textile products in Egypt. This is compared to something like 39% in Japan. But it doesn't mean that we are half or almost half the West European countries. No, because the total production of textiles in a country like America goes up to something like 3 million tons per year. So 40% or 39% is something over 1 million tons. But for us, as for example in the morning, engineer Mohsen Jilani said that we are only producing 200,000 tons. So 40% of the 200,000 is nothing, okay? So the figure is a little bit okay. This is the different applications of technical textiles, and as we can see, I'm not going to go through all of them. It contains most of our life activities: mechanical engineering, environmental, computer, civil engineering, pharmaceutical, rubber, space. We are not going for space, all right, of course. I'm going to talk about the applications I have done in Egypt, okay, and it succeeded. So I'm going to talk about one part which is already applied and the other part which we can invest in, okay? First, in filtration, we can use electrostatic filters like this, okay? We use dust collecting plates for the dust. Believe it or not, this is an information system which we use to operate the filter. It's not to launch a rocket, it's just to operate the filter. In textile filters, to close or to permit the emissions like this in an industry like cement, for example, we use textile filters, okay, and information system like this. We have done all the system, but only we need to manufacture this system. This is to control the pulses over the textile material. This is the only part we import now. If we can manufacture it in Egypt, then the whole filtration system is Egyptian. Also, we have to precisely cut the filter for better performance. We have to calculate how many rows, how many filters per one row. This is a design parameter. We have to use instrumentation to inspect the defects of the filter, however there is a leak or not. We use also auto-page valves to help eliminating water in the compressed air going inside the filter. We have to use thermocouples to be installed into the ducts to monitor the temperature going to the filter. If we do not control the temperature, we can come across with a problem like this, filter agglomeration. Also, we can use a caustic system to clean the filters. We can use a very sophisticated information system to control the sound level. At last, we have to judge whether the filter is working properly or not. Then we use a microprocessor to detect the emissions, the number of particles, converting the number of particles to concentration, like milligram per cubic meter. If it exceeds a certain limit by law, for example 50 milligram in Egypt, then the filter is not properly working. In Egypt, we can experience this scene alongside the Nile beach. Here, on the left side down, there is the filter. The right picture, you can see the result, just water vapor. If we have information about the number of stacks to be controlled, we can, for example, using a central authority like the WE, we can manufacture the filter at half the price, but people cannot buy the filter because the price is very much high. In Textiles, and Textiles as a definition is the kind of textiles used in civil engineering. For seashore protection, we can use computers and software to calculate for very difficult calculations to design the filter to control the erosion against seashore. In road construction, we can use Textile to prevent intrusion between the strong soil and the weak subsoil. In tunnels, we use Textile for separation and drainage. Also, we can use Textile to construct platforms. Also, we can use J-tubes. You know the problem in tsunami. All the places nearby the sea must be protected by J-tubes. This is a simultaneous J-tubes or concrete. We had used this in Egypt in Hurghada. This is a project in Hurghada I have conducted using vertical rather than horizontal. Also matrices to build or to construct columns and inside the sea while the water is there, because in civil engineering to construct a project you have to work in dry area, but here we can work while the water is running. In railway construction with Textile for soil stabilization and as a filter as well. I can elaborate more, but the time is so short. In covered drainage in agriculture, we use the Textile to cover the porous plastic pipes, allowing all the water to dissipate while retaining all the soil. Here, some of the stresses over the Textile in application, puncturing, abrasion, and thus elongation. And here's the hydraulic balance, which must be actually reserved. the filter must allow all the water just to absorb the stresses on the seashore, allowing the water to go this way while preventing all the soil to go in the sea. This is wearable electronic textiles. We can integrate the yarns to produce what's called wearable conductive matrix textiles, or wearable optical sensory textiles, to produce fabrics to be used in application like this. It's just textile with a simple communicating instrument to send messages. We can use textiles also in surgery, vascular grafts, in kidney also we use hollow fibers, and we use it for motor cases. Motor cases can be made of Kevlar, very light material but very resistant to impacts. We can use textiles, electronic textiles, for making antennas, to insulate motors and circuit boards. We can use it to produce structural shapes of glass fiber reinforced shapes like these. We can use it for insulating electric cables. In transportation, of course, we use sensors to inflate bags, or yes, airbags and seatbelt as well. And these are the two items where by law you have to use it in Europe now. In car also we use textiles for insulation, for tire reinforcement, for belt reinforcement. Anti-bullet fabrics. In paper industry we use endless belts. In aeroplanes, some parts of the aeroplanes are made of composite materials based on textiles. We use high performance nerve fabric for as polyester slings, for example. Now we make the alternative in Egypt. Instead of woven, we can use it non-woven, but the non-woven we make it reinforced with Kevlar. We also technical textile. We can make filter cartridge for cars. The testing of technical textile is different from apparels. In apparels, you do not have to test all the apparels for tensile strength and this kind of thing. We just make it for documentation. But in technical textiles, the success of the test means the success of the project, and the failure of the test means the failure of the project. So, believing that there is a law, if the project fails, then you can by law sue the testing laboratory or the manufacturer, because there is a risk of using technical textiles. This is a kind of testing equipment. I have made it myself. Puncturing, of course this is for filtration, puncturing, transmissivity, water permeability, weathering and impact test, wide web strength test, bulletproof and grab test, sieving and air permeability, fuel filter testing. And this is the last slide. Now the rate of production of technical fabrics in Egypt is 120 tons per day. This means something like 36,000 tons per year. I think I have a hope for 300 tons. This can come through, of course, if there is information technology, if there is a good contact between the end users and the manufacturers. Believe me that if we can go to 300 tons, we can increase the investment and working opportunities. Thank you very much.